In this video, we're going to talk about finding zeros of functions. And we're going to see that this is just an application of the intermediate value theorem. So let's remind ourselves of the conditions and conclusions of the intermediate value theorem. So the conditions for this theorem are that the function f of x must be continuous on the closed interval ab, and then we choose a value k that is between f of a and f of b. If that's done, then the conclusion of the theorem says that there is a c in the closed interval ab such that f of c is equal to k. So let's look at how we can use this. So we have some function f of x, and we see that this function does cross the x-axis. And where it crosses the x-axis, we know that's where f of x is equal to 0. So in this particular case, we would be trying to find the 0 of the function f of x, which is located in the orange circle. So first we'd have to choose an a on the x-axis to the left of the 0. And we see that when we choose that, f of a is less than 0. And then we'll choose a b to the right of the 0, where f of b is greater than 0. So if you look at this, the value k is 0 because a 0 for f of x equals 0 is going to be on the x-axis, and that is where y is equal to 0. And certainly the value k, which is y is equal to 0, is somewhere between f of a and f of b, because one of those functional values is negative, namely f of a, and the other functional value is positive, which is f of b. And so the intermediate value theorem tells us that 0 must be somewhere in between a negative value and a positive value. And so one easy check to be certain that you found an interval that has a 0 inside of it is to just check and see if f of a times f of b is less than 0. And again, from our example here, you see that since f of a is less than 0 and f of b is greater than 0, their product is certainly less than 0. All right, now let's apply this to a real example. So the question is, can we find the interval in which we know that there is a c such that f of c is equal to 0 for this function? And so what we notice in this particular case is that there are actually two zeros for this function, and I have them circled there with the orange circles. We would have to isolate one of the zeros. And so let's consider the 0 on the right-hand side. And so we know that we have to check and see that f of a times f of b is less than 0. So here's our function again. We see that we have a 0 there that's just to the right of 0.5. So we'll choose an a, which is to the left of our 0, and we see that f of a is less than 0. We'll choose a b to the right of our 0, and we see that f of b is greater than 0. So we know from our previous slides that if f of a times f of b is less than 0, that product, then there must be somewhere in between f of a and f of b for which the y value is 0. And that's what we're looking for to find f of x is equal to 0. So if we were to select a to be 0.25, and clearly 0.25 is to the left of the 0, then f of 0.25 for this particular function, and I knew the function, is equal to 0.17. It turns out that f of 0.75, which is to the right of the 0, is equal to 0.23. And so when I multiply those two values together, f of 0.75 times f of 0.25, then I get a negative number. And so I know that the 0 to this function's got to be somewhere in between a and b. And so we know that c is in the interval 0.25 to 0.75.